On September 15, 2017, a 5,600-kilogram spacecraft turned itself into a meteor on purpose. NASA's Cassini probe plunged into the clouds of Saturn, transmitting data until the very last second. Scientists around the world watched their screens and for a moment fell silent. The mission was officially over. They thought the science was over too. They were wrong. 8 years after the spacecraft burned, researchers in 2025 and 2026 are still pulling deep secrets out of Cassini's last transmissions. New analyses of archived data are quietly rewriting what we thought we knew about Saturn, its rings, and the strange little moons hiding in its shadow. Some findings, recently published in peer-reviewed journals, are dismantling theories that have stood for decades. And one of them, calmly and almost casually, is changing how we search for life beyond Earth. You need to understand what Cassini actually did to feel how strange this is. Cassini launched in 1997, swung past Jupiter for a gravity boost, and arrived at Saturn in 2004. For 13 years, it orbited the ringed planet, photographing its storms, mapping its moons, tasting its atmosphere, and listening to its strange radio emissions. It carried the European Huygens probe, which in 2005 became the first human-built object to land on an outer solar system world, touching down on the surface of Titan. Nothing in those 13 years, however, compared to the finale. In the spring of 2017, mission controllers began a daring sequence of 22 dives, the grand finale, sending Cassini threading the narrow, unmapped gap between Saturn and its innermost rings. No spacecraft had ever flown there. No human-built object is likely to fly there again. Think about that for a second. Imagine threading a needle the size of a planet while moving at more than 70,000 miles per hour. Cassini did it 22 times in a row, each pass closer than the last. Each pass collected gigabytes of data that, back on Earth, sat in processing queues for years. Other measurements were so strange that scientists set them aside, waiting for better instruments, better models, and better questions. And now, almost a decade after the spacecraft burned, those answers are beginning to arrive in waves. Here's what makes this story unsettling. Cassini's last dramatic images were not actually the final frames it sent. The famous final photograph was taken hours earlier, a quiet, monochrome view of Saturn's night side lit by the dim glow of its own rings. The very last data Cassini sent was numbers, not pictures. Numbers about Saturn's upper atmosphere. Numbers about the strange, near-empty zone between the rings and the planet. Numbers about ion densities, magnetic wobbles, and dust impacts. Those numbers changed everything. In the years that followed, research teams began publishing odd findings one after the other. The rings were missing mass they should have had. The magnetic axis was nearly perfectly aligned with the spin axis, a configuration that, by every model we have, should be physically impossible. And a thin halo of microscopic dust was discovered falling out of the innermost D-ring, gently pouring onto Saturn's upper atmosphere at a rate of roughly 10,000 kilograms per second. These were not small findings. These were the kinds of results that make seasoned planetary scientists put down their coffee, walk back to their offices, and reread the paper twice. But the most shocking piece was still buried in the data, waiting, hidden inside the ice-grain spectra measured during flybys of a tiny, bright moon called Enceladus, a moon smaller than the state of Arizona. And when scientists finally reran that data in 2023, they found something nobody had expected. Phosphorus, the element that anchors DNA. The element that, before this discovery, was missing from Enceladus's ocean like the last piece of a puzzle nobody could finish. The discovery was published in 2023 in the journal Nature. By 2025 and 2026, the implications are rippling through every astrobiology lab on Earth. And Cassini, long gone, reduced to vapor inside Saturn's cloud tops, was still talking, still teaching, still reshaping how we see the solar system, 8 years after its murder-suicide dive. First, the rings. Something is wrong with them, and it has been wrong, hiding in plain sight. For decades, textbook models assumed Saturn's rings were ancient, perhaps 4.5 billion years old, silent leftovers from the formation of the solar system itself, untouched witnesses to the slow swirl of dust and ice that built every planet we see. Then Cassini's grand finale measurements kicked the door in. A 2018 study, led by HSU and colleagues at NASA's Jet Propulsion Laboratory, found that the rings are losing material far faster than anyone had predicted. As much as 22,000 pounds of ice, dust, and organic compounds per second is raining down from the rings into Saturn's upper atmosphere. Now think about the math for a moment. At that rate, the rings cannot have existed for billions of years. The data strongly suggests they may be only a few 100 million years old at most, younger than the dinosaurs, possibly younger than sharks, which have been swimming Earth's oceans for nearly 450 million years. Two competing research teams argue about whether the rings are ancient and stable or young and temporary. But every fresh analysis from Cassini's archive keeps nudging the answer toward the same unsettling conclusion: surface and sample its organic chemistry up close. NASA's Europa Clipper is already en route to Jupiter's ocean moon, carried by the momentum of everything Cassini taught us about Enceladus. And proposals for a dedicated Enceladus mission, a lander, or even a plume sampling flyby are taking shape because Cassini made the scientific case for them, loudly and clearly, with the data it sent home as it died. All of it from a spacecraft that died 8 years ago. So let us pull this together. When Cassini dove into Saturn on September 15, 2017, the world thought we were saying goodbye to an era of planetary exploration. We were not. We were planting a seed. The numbers and spectra Cassini sent during its final hours are still being read, decoded, doubted, and verified by scientists around the world. Each new study opens a door the old data hints was already there, waiting patiently for someone to finally knock. Cassini showed us that Saturn's iconic rings may be temporary, that its magnetic field defies our standard theories, that Enceladus hides a salty ocean rich with phosphorus and chemical energy, that Titan rains methane and keeps islands in alien seas, and that even the death of a spacecraft can be the beginning of a longer chapter of discovery. The grand finale was never the end of Cassini. It was the start of a story we are only now learning how to read. If one machine, sent halfway across the solar system nearly 30 years ago, can still be telling us things we never knew about our own planet, about possible life in the dark oceans of tiny moons, about the temporary beauty of the rings above us, what else might still be hiding in the data? And what else might still be hiding in the universe itself, just waiting for a spacecraft brave enough to look? That is the question Cassini left behind, and we are only just beginning to answer it. So Cassini's final credits are still rolling, and we are still watching. Every bite it ever sent home is still whispering into the deep cosmic dark, patiently waiting for someone to listen carefully.